Hello, hello everyone. So my name is Mingjun Huo from ACAP Network Center of ENET. Yeah, very welcome to join the training course of the ENET project for promoting VOC related capacity building in ENET. So actually this online course we will introduce some VOC monitoring methodology. For some suitable methodology in detail. So these slides, this presentation, I just want to show the overall and outline for some VOC monitoring and measurement methods. So today, this time I will introduce the background and some common VOC monitoring techniques and also measurement method and the summary. So as we know, actually, the VOC, the volatile organic compounds, organic chemicals easily evaporate at ambient temperature, and there are a few kind of sources. Yeah, actually, for us, we focus on the anthropogenic sources. So, and also there are some biogenic sources. For the anthropogenic sources, the VOC will come from the industry process, and also some residential source, such as painting, and also from the vehicle exhaust. And so VOC, as we know, actually they have some health impact. Yeah, especially some VOC, they very focused, but like BTEX, benzene or something. And so some country, like including Japan and also maybe Thailand, and also the international organization like WHO and also of course US EPA, they already have some regulations on the VOC concentration. And actually now especially in the Asian, so many countries still focus on or concern the PM.5 pollution and also ozone pollution. So as we know, the VOC precursor pollutants for the PM.5 and the ozone. PM.5 means the secondary organic aerosol, the SOA, and the ozone. So if we want to make a regulation or policy control for the PM.5 ozone, we have to know the concentration of VOC. And secondly, as I mentioned, so VOC themselves has important health impact on. So if we want to make a regulation for the VOC, such as make a new air quality index, so we also need to understand the concentration, and also we need to identify the main sources. So, but measuring the VOC or sampling of VOC are very complicated or need a high technology and also high cost. Because of this reason, so ENET established this project to enhance the capacity building process for the VOC measurement. Okay, so now I will introduce some common VOC monitoring technology. This is my thinking about what kind of types of VOC monitoring method. Yeah, maybe this is a little different from some other experts. Yeah, so now I just show my own idea. So basically, I think there is some active sampling method and passive sampling method and also real-time method. So for the active method, here is the canister. We conduct instant sampling for canister. It is active method. And solvent tubes is also active method, so we connect by the pumps. Yeah. So passive sampling, we use there is no active pump, so we use the diffusion principle, so we have the passive samples. And also there are very advanced technology for the real-time monitoring. And the real-time monitoring usually GC and connected with some detectors, for example, the PID or mass and others. Yeah. So for the active monitor method, so here is I show some example. We already conduct capacity building in some country by this method. So I will introduce a little bit about the sampling. So here is the pump and connected with the solvent tube. So this is we call the solvent tube method. And the other is the passive sampling. So there is a passive this small tube. Actually, this is also tube, but we don't need the connected pump. We just use the diffusion. So for the active pump, active solvent tube method, we have to use a pump, and this is more accurate, but a little bit expensive. And for the passive sampling, there's no need pump and no need electricity, so this is a little bit cheaper and simple and a little bit low cost. But we have to keep a little longer time for monitoring because we just use a diffusion method. And if the concentration is, especially if concentration is lower, we need long-term monitoring. Okay, so now I show the pictures for or actually capacity building for the monitoring method. For the monitoring, this is the example for the solvent tubes. So left side shows in the small monitoring room, yeah, we put a pump here and connect the tube and connect with the Teflon line, Teflon tube, and go to outside. And outside, yeah, there is we fix the shelter and the inlet like this. So actually, you know, the US EPA has a standard method for the solvent tube and the GC-mass. So in Japan, actually, we follow this standard method. So if your country want to conduct this solvent tube monitoring method, so you can refer the US EPA TO17 standard. Another is the passive sampling method. So this is the passive samplers, and we handmade a shelter. So to avoid affected by the sunlight, so we use aluminum paper to cover the shelter. And this picture shows we installed a passive sampler on the rooftop of ambient air quality station. Okay, so actually there are some factors if we conduct VOC monitoring, we need to consider. For example, first is sampling location. This is the same as other routine monitoring activity. We need to consider urban, rural, remote, or we want to know the VOC concentration, VOC emission from industry, or from the residential area, or other specific environment. And secondly, we need to consider the sampling time. So if we want to know the daily result, daily concentration, or you want to observe the diurnal change. So if you want to observe diurnal change, you need to conduct hourly sampling. I think this is basically online method. So we can observe the diurnal change of ozone and also the VOC. This is actually important to understand the contribution from VOC to ozone. And if we conduct daily sampling after we have enough results, we can also analyze the source of the VOC. And other is the meteorological conditions like wind direction and wind speed. So this is important if we want to know the transportation or the source of the VOC and other components. So we need this kind of meteorological parameters. So there are challenges for the VOC monitoring because the concentration is very changeable, so lower or higher, and VOC has many kind of VOC, so this is very mixture complexity and the cost is higher. So if we conduct VOC monitoring, needs a little bit more cost, higher cost, and also measurement is need a lot of time and laboratory work. So and also the calibration and other interference. And also, okay, now before I introduce about sampling, so now this is the measurement. So the most common now we recommended method is the GC-mass. So this is the diagram for the GC-mass principle. Actually, we have another very detailed lecture related to GC-mass, so I don't talk a lot more. So actually, canister and GC-mass there is also standard in US EPA, so we call TO15. So if you use canister and GC-mass, so you can refer this is the most popular standard, I think. And there are also other determination methodology. For example, the proton transfer reaction mass spectrometry, PTR-MS. So this is very high resolution determining method. And the other is this one, so FTIR, the Fourier transfer infrared spectroscope. So this is also one methodology to determine the VOC. So there is a US EPA standard TO16. So if in your laboratory you have other methodology, you can refer this standard, or we can discuss with our expert to collect more information. Okay, so for the real-time VOC monitoring technologies, there are also some very popular some kind of method. For example, usually we connect GC with other detectors like GC FID, GC PID, or online GC MS, GC FID, or PTR MS, or and also DOS. Yeah. So here is the picture is the GC PID. So we use the we compare our open tube method and this online monitor method in the Mongolia. And so the PID detector is used the UV light to ionize VOC and detect concentration in real time. And FID is burn the sample and to ionize VOC for measurement. And also the DOAS. DOAS is used in some country to measure some gases phase and also can measure the VOC at the same time. So DOAS is based on the Beer-Lambert absorption law. So it is the principle to use the to detection the concentration based on the ability of gases to absorb the unique light wavelengths. So one DOA system can monitor the NO2, SO2, ozone, and BTEX, benzene, toluene, and xylene. So in this case, so we may be important to compare the DOAS with other standard method because DOAS is the open path methodology. So if we want to use the result from DOAS to make a standard, I mean the air quality standard or some regulation, at first we need to compare with the standard point measurement. So here I show some summary for the method I introduced this time. For example, for the solvent tube method, so the advantage is the size is small and very easy to carry and install, and we can detect some kind of VOC, very many kind of VOC, maybe more than 80 kind of VOC. By this method, and easy, but because we need handling, handling to start the sampling, so it may be possible for the contamination, and also it takes a little bit longer time, so maybe daily or even longer. So yeah, some kind of reaction and or contamination. So canister is the maybe popular one. So we can collecting the hold air samples and convenient for sampling and analysis, and also repeat analysis. And some samples is can be preserved good. And there is also some disadvantage. Basically, the how to say, the losses samples turning the storage. And other is online. So online GC, very good sensitivity and high selection and high sensitivity and fast, and can measure many kind of VOC species. But we need the standard compounds. And online GC-MS or GC-FID, so they have very good lower detection limit and high time resolution. Yeah, high time resolution comprehensive measurement species. We can measure many kind of species with high time resolutions. But it's also easily to be affected by the wall effects, and maybe can difficult measure the formaldehyde and high operation and maintenance cost. And their open pass FTIR, it is open pass spectroscope preserve sample in integrity and results in the minimal chemical contamination. And but the detect limited is higher, and we need a data set for the components. And PTR-MS, yeah, there's a we don't need separation required. They're very different technician methodology. So very high time resolution and sample inject directly and high sensitivity and lower detection limited. But there's also some disadvantage. So this is the summary. Yeah. And for the summary and conclusions is VOC monitoring is very important, essential for the health, environmental, and industry safety. So it's important to conduct VOC monitoring. And there are many kinds of VOC monitoring methods, so from passive to real time. So the cost from low cost to very advanced. So we need to choose the most suitable method for our according condition or consideration or condition and our target. Yeah, so this is the third one. We need to choose the proper method, depend on our target and also our accuracy and the cost. And there are some future development trends, so we will conduct advanced analytical techniques and the continuous monitoring system, and also we have some remote sensing, like remote sensors, and also for the data analysis and modeling, there is some more research work on this field, so we can estimate SOA formation and ozone formation, and also conduct source apportionment. Okay, so thank you very much for your attention. So now these slides I just show some introduction and for the outline. So maybe for the next we have other lecture to introduce the methodology in detail. Yeah, so please listen in other material. Yeah, thank you very much.